So I'm going to solve a bunch of questions in a row right now. Um, so question 1, concentration of H2SO4 and Na2SO4 in a solution are given. Molar solubility of PbSO4 in the same solution is dash. The value of Y is what? Okay. So they're given some H2SO4 and Na2SO4, and they've given that Ka1 is very large and Ka2 is this. So we actually have 1 molar HSO4 minus, and we have 1.8 into 10 power minus 2 molar SO4 minus 2 because of the Na2SO4 solution. And since PbSO4 will contribute very less, so first I'll calculate the concentration of SO4 minus 2 using all this. So we have HSO4 minus gives rise to HSO4 minus 2 plus H plus, oh wait, not HSO4 minus 2, it's just SO4 minus 2. And Ka2 is 1.2 into 10 power minus 2. HSO4 minus 2 is 1 molar originally, so 1 molar minus X, 1.8 into 10 power minus 2 plus X, and then we have X for H plus over here. Now, we already had a molar of H plus, right? So it's actually going to be 1 plus X because of the H2SO4 decay. Right. So we have 1 plus X into 1.8 into 10 power minus 2 plus X divided by 1 minus X is equal to 1.2 into 10 power minus 2. So we have 1.8 into 10 power minus 2 plus 1 plus 1.8 into 10 power minus 2 times of X plus X square is equal to 1.2 into 10 power minus 2 minus of 1.2 into 10 power minus 2 X. So this is 0.018, this is 0.012, and that's a 1, so like the difference is very less. So we have 0.6 into 10 power minus 2 plus X square is equal to plus X square plus X is equal to 0. So we have, oh wait, this is some bullshit. We just have to find the concentration of SO4 minus 2, right? So what if I just assume that we have a very small amount of X? Oh, but then X will be negative. We are getting X to be negative regardless. Okay, but they're asking only Y though, right? They're asking only the value of Y. They're only asking the order of magnitude. So, it's going to be in the order of like, let's say, some 1.5 into 10 power minus 2 around. Like, I'm teaching you how to guess, okay? I don't know how to solve this anymore. But then, you know that SO4 minus 2, like, its concentration is going to be around this much, right? So we have PbSO4 gives rise to Pb plus 2 plus SO4 minus 2. And then this is already like 1.5 into 10 power minus 2 plus S. And then we have S over here. S into 1.5 into 10 power minus 2 plus S is equal to Ka to 1.6 into 10 power minus 8. Is S going to be much smaller? So S is going to be like approximately like 1.6 by into 10 power minus 8 by 1.5 into 10 power minus 2. So S is nearly equal to something into 10 power minus 6. So I would assume that the answer is 6. See, again, this might be very wrong. I still have no idea how to solve this. But honestly, 2022 paper was kind of like that. We should probably like look at the solutions of this paper together as well. The answer to question, the answer is 6. The answer is actually 6. So yeah, that's kind of how you guess the answer, but then I don't know how to solve it exactly because this equilibrium is very weird, right? This equation. I mean, sure, we can solve this equation, but then you can't really do that in the exam. If this was an engineering question, we could have done it. Anyways, okay, so next question. That took around 5 minutes something. So we have question 2. An aqueous solution is prepared by dissolving 0.1 mole of an ionic salt in 1.8 kg of water. The salt remains 90% dissociated in the solution. The vapor pressure of the solution is this much. Vapor pressure of water is this much. The number of ions present per formula unit of the ionic salt. So this is, we know that the mole fraction of the solute is equal to RLVP, relative lowering of vapor pressure, which is equal to 60 minus 59.724 by 60. This is equal to, I gotta do something. What is 1000 minus 724? 0, 9, 9, 10, 6, 7, 2. So 0.276 by 60. This is the mole fraction of solute. And 1.8 kg of water is equal to 1800 grams, which is equal to 100 moles of water. And then we have 0.1 moles of ionic salt. So let's say the ionic number of ions present, no? So let's say we have, it's 90%. So we just have to find the number of like ions. So we have X by 100 moles plus X is equal to 0.276 by 60. X is going to be like approximately 0.1. So this can be cancelled. X is equal to 10 by 6 into 0.276. 6 to 76. 6 4s are 24. 36. 6. So 46. So X is actually equal to 0.46, right? And so 0.1 moles, 90% dissociation gives 0.46 moles. So let's say we have AXBY gives rise to XA plus YB minus 90% dissociation. So 1 minus 0.9, X into 0.9, Y into 0.9. So we have 0.1 plus 0.9x plus 0.9y. This is equal to 0.46. So 0.36 is equal to 0.9 x plus y. What is happening? Oh. No, it's correct only. So x plus y is equal to 0.04. 3.6 by 9, which is equal to 0.4. X plus y is 0.4. No, it can't be. Oh wait, this is 0.1. Okay, my bad. Sorry, my bad. This is all wrong. This is 0.1 minus 0.09. Now we have 0.09x, 0.09y. So we have 0.01 plus 0.09 x plus y is equal to 0.46. Okay, so 0.45 is equal to 0.09 x plus y. x plus y is equal to 5. So the answer is 5. That took some time. I actually did not lap it, so whatever. That was, is the answer correct? Question 2 is 5, yeah. Question 3 you got. Question 4 is the reaction of xenon and O2F2 gives a xenon compound P. The number of moles of HF produced by complete hydrolysis of 1 mole of P. Xenon plus O2F2, I think that gives XeF2. Number of moles of HF produced by complete hydrolysis of 1 mole of P. If you 2 moles? I don't know, like again you have to revise the reaction, but is this correct? The answer for fourth question is in fact 2. I don't know how I got that, but yeah. So yeah, this, you should probably like revise the group 18 reactions. If you want, we can like go through that together. Like you have problems in chemistry, anyways. So wait, I'll stop the video, otherwise it'll be long.